Sasha Mim. Today on the 13th of March 2026 we are going to look at differential equations. What is a differential equation? A differential equation is a mathematical equation which consists or which contains a function and its derivatives. A differential equation is a mathematical equation that contains a function and its derivatives. What is a derivative? Is that equation that you get after differentiating a function. We have orders of differential equations. Basically, we commonly know the first two orders. That's the first order. First order differential equations, these are the ones that have only one, that have the derivative only differentiated once. For example, you can have dy dx equaling to 2x. This is a first order differential equation because the derivative we only have the first derivative. Then we go to second order. These have derivative of the second degree. For example, if we have y squared dx squared equaling to y plus 2x. This is a second order differential equations. Now we are going to look at first order differential equations. First order differential equations. How can we solve first order differential equations? What are the categories of first order differential equations? Category number 1 is separable first order differential equations. These ones can be solved by separating variables. Let's take this one as an example. If we have dy dx equaling to 2x, we are going to separate variables. Y variables this side and x variables this side. So we are going to have dy equaling to 2x dx. Now you see we've separated the variables after we integrate. If we integrate dy, we get y. If we integrate 2x, we get 2x squared over 2 plus the integration constant. But this one can cancel off, and we shall remain y equaling to x squared plus c. Then category 2 of first order differential equations, we have linear first order differential equations. For these ones, we cannot solve them using this method. Instead, here we first get the integrating factor so as to solve them. Examples, what can we have under the examples? We can have y dx plus y equal to x. Now how can we solve this? We can get the integrating factor. So our integrating factor will be equal to e power in respect to x. Now what is our px? It's the coefficient here. The coefficient here is a 1. Therefore, our px is 1. Our integrating factor is e power integral of 1 in respect to x. If we integrate this, we're going to get e power x. Now this is our integrating factor. After getting the integrating factor, we multiply it through the whole equation here. So you're going to get ex dy dx plus ex y equaling to e power x times x. But we can see that this one was got from d into y ex equaling to ex times x. We can multiply this the other side. The remaining will be into y dx equaling to ax times our x, then dx. Integrate. If we integrate this, we are going to remain with y e power x equaling to, this one shall remain the same. Here we get integral e power x times x dx. Now, to integrate this, we are going to integrate it by parts. We are going to consider this. Consider integral e power x times x dx. Now we have to get to the u and our v. From here, if we look here, our u is x. U is x. If we get to du dx, this will be a 1. Therefore, du is equal to dx. Then our dv is e power x. E power x. If we integrate with respect to x here, we shall get our v as e power x. Then to get the integral of this, now the integral of e power x times x dx shall be equal to uv minus integral of v du. But our u is x. Our v is e power x minus integral of v, which is e power x. Our du is dx from here. So we get x e power x minus, this one remains the same, minus e power x plus c. Then we go back to this. Y e power x shall be equal to this one, x e power x minus e power x plus c. We can divide through by e power x. Shall remain with y equal to x minus 1 plus c e power negative x. So this is how we solve linear first order differential equations. Let's look at the applications of differential equations. How can we apply them? Applications. Of differential equations. How can we apply them in day-to-day life? How can we apply them with different fields? The first application we have is determining population growth or decrease in sectors such as biology, for example, they can give you a question and they say the rate of growth of a certain population in a certain area is directly proportional to the population present. There you form a differential equation, and they can further tell you that initially there were this number of people. That's your initial population at time t equaling to 0. Hope we can have an example. We have an example here. The rate of population increase P is directly proportional to the population present. Initially, population was 500, and after 2 years, population became 1,000. Find P after 5 years. We first form a differential equation. They've told us that the rate of population increase, dP dt, is directly proportional to the present population. Therefore, dP dt equal to a constant Kp. We're going to separate variables here. Shall get dP over P equaling to K dt. After we integrate, here we get ln P equaling to Kt plus C. This is the integration constant, but they've told us initially P was 500, which means at t equaling to 0, P was 500. We get ln of 500 equaling to K into 0 plus C. Therefore, our C is ln 500. Then after 3 years, when t is 3, population was 1,000. We get ln of 1,000 equaling to 3k plus ln 500. Because our C is really 500, we can bring this one this side. We get ln of 1,000 over 500 equaling to 3k. We get our k equaling to, here we get ln 2 over 3. Therefore, the differential equation now is ln P equaling to, our K is ln 2 over 3 T plus our C, which is ln 500. Then they've told us to find the population after 5 years. at t equaling to 5, p is unknown. Here you can substitute in mean p equaling to our 5 over 3 mean 2 plus mean of 500. Then here we can get our p equaling to e into bracket, e power into bracket 5 over 3 mean 2 plus mean 500. Whatever the answer you get, we're going to get p as 1587. This is our p after 5 years. Now this is the first application. They have several applications. Differential equations can be applied in engineering, they can be applied in medicine, and so on. Thank you. Bye-bye.